So in the last lesson, we saw just what kind of performance benefit we can get by storing all of our data in RAM instead of storing it on disk and reading it into RAM when we need it. But the next question that we'll have is, but how did we get all that data into RAM in the first place? So let's first look at how information is normally stored in a database on disk. And the way that that works is to take rows of data, one row at a time, and start filling pages of disk storage with those rows. We just start filling the page with rows till we run out, and then when we run out, we go on and create another page until we have our entire table filled out into the into disk storage. Then when SQL Server needs that information back, like say it needed row 3, it would go to page number 1 and get row 3, and it's doing this, transparently to the user, but this is how data is stored. The compression that we can get is really limited to within the page. So if there is a benefit to compressing data across pages, there's really not much that we can do about that because of the way that data is stored row by row by row. But if you think about it, we compress data by finding redundancies and then factoring them out. So if we have the same value in a row over and over and over and over and over, we can compress that by not storing it over and over and over. So if we look at that fact store sales table that we were querying in the previous lesson, we can see that in all these columns we just have so much redundancy. The store key appears over and over, the time key over and over. The item key a little less a little less redundant, but we have lots of null values that are stored over and over, and units sold are zeros for many rows in some cases. So there's a lot of redundancy, but we can't really take advantage of that redundancy when we're storing page by page like this. So we're going to need a lot more disk storage, and because we need so much disk storage, we can't really easily store so much in RAM because we just don't, we do have a finite amount of RAM at the end of the day. So let's contrast that with the way VertiPack is storing data. Instead of a row storage strategy, VertiPack uses a column store strategy. And what do we mean by that? So in the previous slide, we saw that pages of information were stored with rows and rows and rows and rows and rows. What VertiPack does is it takes pages sort of like the ones we saw before, and it's storing things, the entire column together. So if you think about that table that had all those redundant values in the rows, all those redundant values are going to be together on the same set of pages. So we can get tremendous compression abilities, because now if the entire page, for example, was all nulls, we really only need to store null once and then say, oh, by the way, it's null for every field, or something like that. Or maybe the value is a string that's really long. We can store that string just one time and then just make a footnote that says, oh, by the way, all of the rows on this on this page are the same string as the first one, and now we can get 10 times more rows on that page. So we can get much better compression characteristics. And then as the rows are loaded into, as the columns are loaded into the column store, this is what it begins to look like. So column 1 is on a couple of pages in this diagram, column 2 is in a couple pages, but we're splitting this up and storing it by column and taking advantage of tremendous compression levels. And because we have tremendous compression levels, now we can fit way more information into RAM, and that's fundamentally why VertiPack is able to store so much data in memory. This diagram summarizes the tables that we were just querying and shows the benefit of using VertiPack for the column storage rather than the traditional row storage that we're using with our SQL Server. So in our 250 million rows in the fact table is by far the largest portion of our storage, and that is quite normal. That's most data warehouses have that profile. On this column we have the SQL size, and this is an uncompressed SQL storage of about 30 gigabytes. If we compress that with SQL's page compression, perhaps we could get that down to 20, something like that. So we could make that a little bit smaller with the more recent versions of SQL Server, but it'd still be a substantial pile of data that we'd have to store in RAM if that's what we were trying to do, and probably not that practical. It wouldn't take too many tables to saturate our server if we started storing that much data in RAM and querying it from RAM. But with VertiPack, because of of the column store and the compression levels that it gets, which are exceeding 10 to 1 in this case, that data size is only consuming about 2,700 megabytes or 2.7 gigabytes. And on this particular server has 32 gigabytes of data. The 2.7 gigabytes, we're really not that concerned about that at all. It's not a big footprint considering the performance gain that we get. So that's the reason that VertiPack works the way it does. That's why we can store things in RAM, and because we can store them in RAM, we can get blindingly fast query performance. Now, I won't diminish the technology. There's certainly more things in VertiPack that make it fast, but fundamentally, this is the biggest portion of why we get the performance we do from VertiPack.